Hi, I'm Bill Hurd.
And I am Alan Wolke, W2AEW.
That's a weird last name.
Well, it's my amateur radio call sign now.
Okay.
A lot of people know me by ham radio, and it's also the name of my YouTube channel. So.
Okay. So, and I'm just, and this is, we're doing an installation of the Dinosaur Den here today, and Fran's not with us, but Alan here is our guest host, and we still have old, interesting crap to show you, which I shouldn't call it crap. It's cool stuff.
I don't know. Some of it hasn't been powered up, so it could be crap.
It might be crap.
Yes.
All right, so show us this first thing here. What do you have going on?
Okay, so this first thing here is a Weston Electric Model 45 DC ammeter. I don't know if you can maybe be able to pick this up on video or not. It's pretty hard to read even without the camera. But it's got a couple of patent dates on here. The earliest one is from November of 1888, and the last patent date listed here is July of 1901. So this thing was probably produced in certainly the early 1900s, and this thing, I don't know if you pick this thing up, it's got to weigh 10 or 15 pounds. Just
right,
try to move that thing. But
what kind of wood? It's probably a heavy wood.
I don't know. I mean, it's probably been refinished 100 times or whatever. But what I thought was really cool about it is just I just like kind of the antique electronic stuff,
right.
And I don't use it for anything other than just to look at. But what was cool, if you take a look here, this is actually the calibration certificate, and it says this was calibrated correct within 1/2 of 1% of full scale at any value of any part of the scale at 75 degrees Fahrenheit. Okay, and then to get the most accurate readings, this is the calibration part here, is multiply the readings that you have by 0.00028.
Wow.
But if you're at 75 degrees Fahrenheit. And this was done in May 19th, 1923. So that's the last time this thing was documented and calibrated. So it's like a 50 microvolt drop on this thing at full scale. I'm not sure what the meter impedance is. Again, I've never hooked anything up to it.
What do you think the patent is for? Is it just for the mechanical motion? And
yeah, I would think it's for the meter movement. I don't know if it's like a joule type of thing. I haven't taken it apart to go take a look at it.
And certain things to remove nonlinearities, the way a winding might sit or something.
Yeah, just so that the meter or the needle will sit and float properly regardless of orientation and that kind of thing. And you got the nice mirrored scale there so that to get rid of the parallax, that kind of thing. But the other reason I kind of picked it up when I saw it is that it's made by Weston Electric. And I went to school in Newark at NJIT. It used to be Newark College of Engineering. And one of the buildings that I took classes in was the Weston building, which was the home of this company. So, so I figured it's just kind of a neat bit of history to kind of have and kind of fun thing to go look at.
Yeah, so, absolutely. Where do you think this would have ended up? Would this been like used out in?
Well, given that it's designed to be used with some external shunts, and it's a relatively low current meter, so I wouldn't think it would have been in the power industry, but just more in early electronics development and things like that.
So probably in the lab, not so much like out to
I don't think this was really a
communication wires or something like that.
In fact, I've got a unit that's kind of in a similar case I was going to bring, but I didn't bring it. That was actually owned by the telephone company, and it was used to check audio levels on phone lines. But it was in this almost the same type of a case, but probably dated to the 40s or 50s as opposed to this thing, which is early 1900s.
Right. Now, if you're a dinosaur, you remember what it's like to make a long-distance phone call, and the distance you talked, the signal got worse and worse. Nowadays, we take it for granted.
Oh, yeah, absolutely.
But you would hear echoes.
Oh, yeah, and then you get the party lines and all that stuff. So.
Oh, yeah. When I first moved in Indiana, the phone, you had to count the number of times the phone rang.
Yeah.
And you had to pick it up.
Sure.
To listen before you talk.
Make sure somebody else was
right.
on it.
And imagine like relying on your neighbors to be polite about, can I talk now?
Yeah.
No.
Yeah. Well, what did they say when they first invented the telephone? That somebody could say, well, I can envision one day that there'll be one of these in every city.
Yeah.
Right. And they turned to him and said, "What are you, crazy? String wires all over the country? You're nuts. That'll never happen."
Right. Well, one time I said, one day there'll be a web address on that UPS truck, and everybody thought I was nuts. Right. Of course, now you wouldn't see one without a URL on it.
Right.
So it's that's cool.
So it's just a neat piece of just old
and you said you put a shunt on it and saw that the movement got less.
Yeah, so like I said, I've never put a signal through it to kind of measure it, look at its accuracy, but I did verify that the meter movement works. And a good tip if you're looking at picking up an old voltmeter or something like that at a Hamfest or an ammeter, what you do is take a look at it, first wiggle it to see if the meter itself is free and it moves.
Right.
And that's one good thing, because sometimes they'll get grit in there and they won't move. The other thing is grab a short piece of wire and connect up the positive and negative terminals. And then as that moves, it generates a back EMF and will actually resist
Right.
the meter movement itself. So if you see a change in how much that meter floats when you put a short there, that tells you the meter movement is probably okay.
Right. Oh, that's very cool.
So.
Yeah, the I don't know if you saw, we had a galvanometer on the
Yes.
first day,
Yeah.
and I think we grabbed a lemon to power, you know, because we didn't want to blow it up. Yeah, the lemon probably still could, but at least
this thing it's got a, I said, I think, what does it say? It was a 50 millivolt across the terminals when it's at full scale. I don't know how much current it is. I think it even indicates what the full scale current is, but they just kind of set it as millivolts here because this is designed to be used with an external shunt. So you'd get a shunt that is 50 millivolts full scale at the current you want to read, and then this would read that, you know, at full scale for that particular
Right.
shunt.
So yeah, your shunt getting loose or something could result in damage to this guy.
So you never
no
use this
idea
by
what
an
the
ammeter
shunts
all
were.
by itself. No, listen, I've never seen any of the shunts for this, but they're, you know, it says it's only for use with the shunts, and they're these 50 millivolt
Right.
shunts. At
Well,
full
if
scale,
anybody
so.
knows where there's a shunt for a Weston DC ammeter,
Model 45.
so yeah, one last shot of it here. So yeah, very cool.
Very cool.
Yeah, I like the dates on it and stuff.
Yeah, just kind of stamped in there, guy's hand signature when he did the calibration.
Yeah, I don't even think I was born in 23. So
I don't think I know my dad wasn't born in 23.
right,
so.
right. So, all right, very cool.
Cool
So
stuff.
what else we got?
So the other thing I brought with me, and this is just pretty cool, something called a Fluke differential voltmeter. They still make differential voltmeters today. This one dates from 1965. It's a model 881 and Alpha Bravo, and the 881 Alpha, 881A was kind of the main model. The B suffix indicated that this could also be battery powered. Now the battery in this thing is long since gone.
Probably a lead acid or.
Oh yeah, I haven't. You know, I got to pull it apart to kind of see, but the battery obviously doesn't work. But you had switch operations where you could charge a battery or operate off a battery. So if you needed to make truly floating, galvanically isolated measurements,
right.
you know, from a line or something like that, you could go do that. But the key about this thing, this will measure voltages up to 1100 volts to an accuracy of 0.01% in 1965.
Wow.
Okay, and what I love about this, it's kind of an electromechanical type of.
So it would have been used on like high voltage supplies for critical tube-based stuff.
It could measure all the way down to 1 volt full scale to
for like the
1,000
grid.
volt full scale.
So it's good for anything around the tube.
But it's DC. Okay, this is
Right.
for DC. But so that it'll do 1 volt or less than a volt. It'll go all the way down to 0.01% of the full scale reading. And what I love about this is that what it has, it's got an internal voltage reference. Okay, and then a very precise Kelvin.
Kelvin temperature compensator.
It's a temperature compensated reference voltage.
Right.
And then it's a Kelvin-Varley resistor divider.
Okay.
Kelvin-Varley divider is kind of interesting. That allows you to cover multiple decades of voltage division with not as many resistors as you would if you had to string them all together. Okay. But it allows you to kind of step in decades. Each time you add a stage, you're adding another decade of resistance. So what we're doing is we're basically taking that reference voltage internally and adjusting a scale on that, taking our unknown external voltage,
right.
comparing the two, and then adjusting the divider to null out the voltage difference.
Because coming back to null is more linear than trying to display
right, and you know
offset.
where you are. So I love this thing because all the knobs kind of just mechanically turn the numbers and things like that, which is great. And if you take a look here, if I adjust the scale here, or I adjust the range, this scale changes.
Yeah.
Okay.
And
also my decimal point is moving, and this is just all mechanical, which is beautiful. Like this one just kind of pops up here. You see how that just kind of pops up? The other one is just little white dots that appear in between.
And Fluke set the standard for this. Why wouldn't you have the decimal moving and the scales rather than have a little sheet of
exactly. So because all these are just controls on that divider.
Right.
So you adjust the scale of it, you adjust the null scale. Now what this scale will do is you basically start off by going on a high range and going to kind of the voltmeter scale, hooking up your unknown voltage, and getting the approximate voltage value.
Right.
Then you know what voltage range to go down to.
Okay.
Then once you go down to that voltage range, then we can start doing the nulling process. So you go to 1, you should get about the same voltage deflection you had with all the zeros dialed in here.
Right.
And then you say, okay, I'm reading about 0.4 or whatever on the scale, and you adjust these things to try to get as close to a null as possible. Once you get as close as you can, you go to the next stage. Multiplies the scale by a factor of 10.
Okay.
Okay, so you get 10 times more sensitivity. Then you work your way down and adjust the other knobs. Go down again, adjust the other knobs, get down even closer, get down to the last one, and fine adjust it. And then this voltage that we read right down here is the voltage that you applied.
Wow.
So it's just really, I mean, it's a long way of getting a precise measurement.
But once you know how to work it, your hand probably just flips right through it, and you're there in 5 seconds.
0.01% accuracy without having a 6.5 digit voltmeter.
You know, I don't even know what that would be offhand, but this is how we do it these days. Keith Lees and stuff.
Oh yeah, absolutely.
But this was,
this
is a John Fluke.
Yeah, these are the things that would be in the calibration labs and things like that would use to calibrate meters like that.
Gotcha. Because I was going to ask then what would be a good use for that kind of thing.
Yeah, that's kind of really where I think these things were found more than anything else. But this one kind of found me, and I just thought it was pretty cool.
Now, I wonder if this would have had a sticker tracing back to Bureau of Standards or something.
Yeah. Because the only thing you had to calibrate the voltage standard that was in it.
Right.
And then there's a couple of trim points that you'd adjust, for some of these other things, and it's all kind of. I've even got the manual for it.
See, now I used to work in a digital scale company, so we had a room.
Yeah.
With no air flowing in it, and then there were our standard weights that came from Bureau of Standards, right? So what would have been the thing in the lab that was from the Bureau of Standards? What was a perfect volt or something? Do you think?
I don't know. I'm not a metrology person, but I think there were there's kind of standard cells that kind of were standard voltage out to so many decimal points.
Yeah,
I really don't know.
I wonder what that'd be like. Yeah, because it's easy for a scale as long a weight, right? Which is as long as you're not banging it and knocking pieces of molecules off or evaporation. I mean, eventually we'd have to do them, even though we didn't hurt them at all. They changed their weights just due to
another neat thing about this too is that up to 11 volts, the loading at the input here when you're at null is infinite, because you're essentially fighting against the other one, and once you're null, there's no current flowing anywhere. When you get to the higher scales, there's actually another divider in there that
draws it down a little bit.
Gives you a 10 meg input impedance. But at the 10 and 1 volt scales, when you're nulled, it draws no current. So it's pretty cool.
And I learned about nulling out as a technique. Again, I worked at a digital scale company, and we had your standard AD converters and stuff. And then we did a forced restoration load cell, and I had been to college, I wasn't good at math, and I was the newest kid in the department. He dropped on my thing and said, "Here, do this. Here's our competition. Figure out how to do it." And what it was is you would increase the current so that it returned to a null. So it was a coil, and you put a load on it, and then it would bring it back to a null. And of course, all the nonlinearities and stuff all nulled out. And that was the great. So my first one was an oscillator.
Offset. Would that null out any nonlinearities as well? Or?
Well, it turns out there was a couple windings in the coil just for saturations and things like that, but once you've got those down, then all the other crap. And of course, starting from a math background, my first thing was an oscillator, because I didn't understand critically dampening and stuff. So I'll have to tell you the story, because my thing was, if I had to do the math to critically dampen it, what happens to tolerances in production? So I found a way to break the cycle and just not make it critically dampen. I made a capacitive break, and just as soon as it lifted off the thing, it would basically bank in a whole new thing, only it was capacitive, and then it would settle. In 1 second, it would go from 0 to 5 volts, and the second settle to one part in almost 20,000.
Oh wow!
So it was two different circuits kicking in. So, but that's where I learned about nulling.
Cool.
So very cool.
So I thought that was neat. It kind of came my way, and I figured, and the funny is, no calibration sticker on it. I don't know the last time it was calibrated, but I don't have even 5 or 6 digit voltmeter at home. I've got the best voltmeter I have is a Fluke 87. So what I did is I just checked the voltage on here. I can get the Fluke 87 to show 4 digits, and this thing matched it within 4 digits. And this thing might not have been calibrated in 40 years.
How many years? Yeah,
but it still works.
And I bet that they probably, like the resistance, all the contacts and stuff are probably in there so that they're not critical. There's ways you can do it so the resistance doesn't impact right on top of things.
I don't know. I got to look at the schematic and see what values they use in the Kelvin-Varley divider. But the Kelvin-Varley, each bank is typically, I think it's a factor of 5. The resistors used in one bank are all the same. The next bank is a factor of 5 less. The next bank's a factor of 5 less. And the way they're kind of interconnected is what gives you the decade changes. And so I don't know. And the lowest value ones are probably still,
Is it a multi-dimensional array then? It's not just a series of resistors. It's got a bank next to it in parallel.
There's a bank of resistors, and then the connection is actually made through a couple of them. And then there's another bank.
So it starts to almost be a square
bank is
term,
11.
like thing. You know how in square resistance,
Yeah.
things start to null out too and stop being critical.
Yeah, each bank is 11 resistors.
Okay.
And then there's another 11 that are a factor of 5 less than that one.
And there's a
Another
couple
bank's a
interconnects
factor-
back to the first one.
Right, and there's a couple interconnects going back that when you're making these changes.
Right.
So there's a pretty good wiki page on it. So that's,
Yeah, I'll have to check out because I hadn't heard that before
Yeah.
you said it. You know,
Yeah.
because I always, when I hear Kelvin, I think of
so it's a Kelvin
Varley.
divider. So it's kind of the technique that allows you to kind of go the decade by decade type of thing.
So,
But,
and how many digits?
let's see. It's basically just 1, 2, 3, 4, and then another 2
Okay.
there.
So
So
I had to turn mine on just to remember how many digits.
okay.
And you know, probably that digit doesn't matter. You know?
Right. Yeah.
But I had always, you know, nowadays eBay, you
Yeah.
know,
Oh,
so
sure, yeah.
because I'd always wanted, you know,
Yeah, anything I do on my bench, I mean, I don't need more than 2 or 3 digits of resolution.
Yeah.
So
Yeah.
but so I don't really care to have I don't need a big bench voltmeter. My Fluke 79 or 87 work
Right.
just fine for what I do.
you know, actually, I got that. It was for one of the Hackaday videos I was doing on analog computation.
Okay.
And
Yep.
so that's
Oh,
why I
yeah,
grabbed
yes.
it because
Yep,
it
I
was
remember
I
that,
could
yep.
do the multipliers and it'd go way down.
Yeah,
and
those
stuff,
little
so.
blocks for doing all the analog computer stuff.
So.
Very cool.
Okay. You have anything? You got other stuff to show us here. You want to pull it up on the bench?
Yeah, I've got some.
All right.
Yeah, let's do it. Did you build that or did you get that?
I built this when I was a
Okay.
kid.
Yes, I did too. My parents were like, "What do you want that for?"
The thing about the H, one, I accidentally wiped the letters off while
Oops.
cleaning it.
And your power was turned on.
Yeah.
So you don't have to-
But this foam,
yeah. Oh yeah, that disintegrated.
Oh, it's horrible.
And it got a little sticky.
and it leaves behind the thing. I
yeah.
spent gosh, 6-7 hours
Yeah.
cleaning the case up. This is
Yeah.
fine, meanwhile, and
Right.
it's part of that cleaning process where I wipe the letters off
Yeah,
like an
yeah,
idiot.
yeah.
Probably got the black, but no, it took more time. So if I were to build a Heathkit today, I would never use that foam again. And it was probably would you say, an open cell neoprene type?
Yeah, some kind of black, cheap black foam, but
Yeah.
I remember after many years I opened that up and it was kind of, you pushed it and it would stay stuck and it was
Right.
all sticky. It got all over everything.
And then eventually just and it's kind of like whatever, the cross bonds are all broken just
Yeah.
due to being old.
Yeah,
Kind of like my
well, the good thing is I got rid of mine before it did any real damage to my meter. So, but,
you know, I'm still looking for a manual for that.
I've got a paper one I could scan for you. I don't.
Can I get that from you?
Yeah.
Because I actually, it's interesting. I even opened it up and looked at it and going, I'm not sure I would solder it that way these days. I mean, it was okay because I would have had a little Radio Shack pencil.
Yeah.
And at one point, I even lost the tip, which I found 3 years later, like in the carpet. So I'd put like a screw in there and Dremel, you know,
or a piece
sand
of
it.
12 gauge copper wire.
Yeah, whatever you can. Yeah,
Yep.
yeah. So it's
Then it would be bending when you're trying to solder.
but I took that around to everything in sight.
yeah.
I mean, I learned to see a lot about like even corners and stuff, either as active or passive.
Oh, it's saying, and you learn what IF frequencies you're running here and there,
Yeah.
what the LO frequencies are. I mean,
that's-
just by using
That thing, and so I'm still like in 7th or 8th grade when I had that,
Yeah.
7th grade, and I'm learning to see waves.
Yeah.
You know, so it has started that intuitive feel for
sure.
electronics.
Yeah.
You know, came from being able to tell where it's.
I think I got that when I was in high school. I was working at the TV shop. I think just reading up, I was like, just being able to use it to measure unknown inductors and things
Yeah.
like that and that kind of thing. So just a great tool.
And you know, the other thing that was good for learning back then was the variable capacitors of the day.
Yeah.
What that visual, my
Oh, yeah.
capacitor's broken,
but
but that visual of
missing a
this
plate
thing, it was so intuitive. Oh,
Yes.
there's air in between, and it's but that's changing, but the amount of next, and it makes it easy to see what a variable capacitance is.
Sure.
Yeah, we had it. They're big and bulky, but it was an advantage for us.
So I love the old grid dip meter. I think they just called it a dip meter because there's no
meter.
grid because it's not vacuum tube, it's a FET. So I think they just called
that's why I think it was called a grid.
Well, this one they just said dip
Solid
meter.
state dip meter.
Solid state dip meter instead of a grid
That's
dip
fine.
meter.
I've
But we
always
still
just always called it a grid dip meter.
Me too. So.
And but there's actually a story you would energize. God, I'm gonna have to read up on it. When you actually activated the dip you got out of that thing was a very energetic thing when you used it the way it was originally designed, and not just going around with coils and stuff. But I'll have to read up on it.
Well, I guess there were really kind of two ways. One is as
because the Q of the circuit was
absorptive type
Right.
meter where it would suck energy out of
Right.
You know, whatever you were going up to would actually suck energy out, and because it was drawing energy from your circuit, the grid current for the oscillator internally would go down.
Right.
And that's the dip that you were looking at.
Right.
Okay.
Right.
But then you could also use it as a signal source.
And you could get, I don't want to say super regenerative, but that could cause that signal, or that current to jump way up, and that dip.
Right.
And that's why I was thinking it was almost like a combination. The Q was in effect, the resonance, all these things, and you get this huge effect from a little a bit of input.
Yeah, it was a great tool. And as I said, it gave you a lot of intuitive feel for circuits and frequencies and things like that. So
mine ate batteries. Mine just killed batteries. That's
higher well, if you leave it on like that,
well, it's been on for 17 years. I mean, you know. So, all right, what do you have here for us?
So the other thing I brought, you know, I mean, as you know, I work for Tektronix, but I've only been working for Tektronix for almost 9 years. It'll be 9 years this summer. But for you know, the 25 years before that, you know, I was a customer, so to speak.
Right.
You know, I just used all kinds of test equipment, but always kind of a pretty big fan of tech. And you know, we talked earlier about working in the TV shop. When I worked in the TV shop, I used a 465. Okay. This was probably one of the staples of the industry, probably one of the most popular analog 2-channel 100 megahertz scopes that was ever made. This is the 465B. There was a 465 without the B that came before it. Had a couple of different changes. But I used one of these when I worked in the TV shop, and just fell in love with it. Learned how to use a scope, learned what a scope could do for me, learned how to get the most out of the triggering controls and all that.
I was going to say, and then if you can do your delayed trace.
Delayed trace
that's
and all that
the
kind of stuff. Yeah, that was the
that.
Zoom of the day, right?
Yes,
that was the Zoom of the day. But so this was it, and I think I graduated college in '85. I think I was working for 2 years or so, and I was always still playing around with hobby electronics. And a friend of mine said, "Hey, I've got this scope for sale." So I think I paid in 1987. I probably paid $250 for the scope, which, you know, $1987 when your first job was a fair amount of money. But I've had this thing since 1987. I've had to repair it once. And the repair was actually a resistor in a power supply circuit that had actually changed value. Weird.
Yeah.
But it's worked fine ever since. Still works fine. And if you know, some of my videos that I have on my channel, I've actually used this scope because it's one of too many that I've got in my shop. So.
Weren't the early ones? I'm saying I see LEDs. I seem to remember a lot of incandescent light bulbs on my first ones.
465. All of the indicators for like when you uncal, when you go to uncal, things like that, those were all incandescent.
Yeah.
The B is when they went to LEDs on
that's
those.
That's what I was thinking. So.
The B's also changed the way that the dual time base worked.
That's how I was also thinking it was a change in the
because on the non-B version,
it was an A and a B.
It was
always
a mixed,
at the same time.
It was a mixed sweep.
Right. So that's what I'm trying to say. They were on at the same time.
So what you do is if you kind of pulled the knob out and adjusted the B time base, you went to a mixed mode, and what would happen is the sweep would start off at the A rate, and then at the delay setting would jump to the B rate.
And meanwhile, the intensity is jumping then because of the time it's spending on the phosphorus. So you had to learn to read through that. Yeah.
So the B changed it to kind of the more modern way of doing things.
Wait a while
by having
trace.
a separate sweep. So when you set up a dual time base and you go to Alt Display, you get one complete trace at the A time base, and then the B sweep at the B time base based on the delay position and the B triggering. So it was really kind of a true dual trace triggerable type thing. So. And then you get to like your 2465B, behind you there, kind of expanded on that and being able to kind of separate it out even more, make some measurements and all that kind of stuff. But this was kind of the.
What's the bandwidth on this?
This is a 2 channels, 100 megahertz, and just 1 mega ohm input impedance.
I didn't know that the 465s. I always thought for some reason they were 250 meg.
You're thinking of 475s. The 475 scope looks just like this.
Right.
But that was the one that was 200 or 250, depending on the model.
And of course, in a TV shop, you wouldn't have needed any. I think we probably had a 1550 meg ICO or some weird brand.
So these were 2-channel 100 megahertz. They had the Tech Probe interface, so that when you plugged in a 10x or 10x probe, it would automatically sense that and basically illuminate either the 1x or the 10x.
And that's
scale.
still in incandescent.
Those are still in incandescent.
Okay,
they still light up yellow when you
still the one thing I expect to break on these, not a resistor.
Yeah, they're a bear to get to if you had to replace
probably,
them. But otherwise, the scope still works great. You know, it's as I said, it's one of those things that I don't know. I probably will never get rid of it because it's the first scope that I had.
That's back when a beam finder could save your ass.
Yes, right.
Okay,
Where did that trace
go? You would actually
go?
lose it. Yeah,
Right.
it's small and down to the bottom, and then, by the way, delays on.
Right.
So
I brought that along just because it's it's
near and dear to your heart.
Near and dear to my heart, and also to kind of talk a little bit about the way things used to be done with like service manuals and stuff like that.
Right.
So this is actually the service manual for this scope. I mean, this thing is the size of a phone book, or at least an East Coast phone book.
Right.
They are in the other parts of the world, but what was great about these things, not only was it just a list of every control and how to use it, so it was kind of like the user manual, but it also had a whole theory of operation of every circuit, block diagrams for every circuit.
And you could learn from this too. I mean, it wasn't just to fix it. You could learn how this stuff works.
Absolutely, because everything was taught to you. I mean, like here, this tells me what transistors were used in the regulating amp of this thing here, or the input amp was this transistor, the beam finder switch was this. All those designators are here. And if you look at like the CRT circuit, that little diamond, the 11, the 11 means go to section 11 here, which was a little tab. And here's the CRT circuit with that same 11 on there. There's the schematic for it. And here's all the waveforms that should appear when you're servicing that part of the circuit.
Right.
So, and then all the component designations, where they're located on the map, like
that's
2A,
back when we
when the old maps like that. So every section had fold-out schematics like that, signal flow diagrams, there's troubleshooting guides. I mean,
let's see if we can get a picture. Put that right here.
Yeah.
Whoops. Let's do this. I don't know if we can see,
Yeah.
but the picture of the tube, it shows.
Oh, yeah.
It shows what it is.
Right. You got the heater. You got the focusing grids.
Yep.
You got the vertical and horizontal deflection plates.
See, now I would have tried to figure out which was which, but yeah, I knew those.
So I don't know which way they oriented it, but
yeah,
and then you got the acceleration potential. That's trace rotation. There's actually a little bit of a grid in here that, these old analog scopes, if you moved around, the Earth's magnetic field might cause a little bit of a tilt.
It's in a different direction. Yeah, it's actually being accurate.
Right. So the trace rotation, a little coil there to compensate for that. So even though there was mu metal around the shield, around the traces, around the CRTs, it would still kind of be affected by the magnetic field sometimes. But these, I just love these manuals because I spent when I got this scope, I very shortly after that went searching for a manual for it because again the amount of stuff you can learn just from these troubleshooting diagrams and things like that. Tektronix was fantastic about having this kind of stuff. Unfortunately, you can't get this kind of detail available with today's equipment. But
and I couldn't have afforded something like this. But that's what you were saying earlier is part of the reason I worked for people. Would never have thought about not working for a company was let them buy this stuff because I couldn't afford it.
Sure.
And now thanks to eBay.
Oh yes, we can get all this stuff. But like I said, I paid $250 or $275 for this in 1987.
Yeah.
These guys in good condition, you could probably still get $150 for about what you pay for them. But they're still great analog scopes.
Yeah.
And people always ask me all the time, do I want an analog scope? Do I want a digital scope and things like that? To me,
have at least one of these in your
one of each.
Yeah.
There's really good reasons
for it. Which you see. That's exactly what I have. And there's times when I say I need to know what's going on. Now with the scope things, show me what's going on, and I reach for my analog.
But just the intuitive feel, instant response. There's no software or firmware between me turning the knobs.
If you feel like part of the waveform's missing, too high, too big, on the digitals, other than that, then I get out my analog.
Because even these, that was the thing with these scopes too. They were specifically designed with things like really fast overload recovery. So if you want to look at the ringing that was going on at the top of an edge of a pulse or something like that, you just crank up your volts per division, adjust the position, and actually look at it. Right. You didn't care that the bottom of that waveform was down there.
Well, and I would do that. I would make it so only the top would show, and other than it would spray the sides and light up. So you found a balance between the, and I've told you how the way I would use my eyes as a storage scope back in the Commodore days on troubleshooting DRAMs. is I would stare at it because I know there was something in there. It's not, but here's a RAS, here's a CAS.
Right.
I'm getting a corruption. I'm going, who's moving?
Little ghosts popping up.
Yeah,
in there,
and who's moving while CAS is going, because just against the law.
Yeah.
And stare at, and then look away and look at a white thing, and I could see it in dark, and I can see dark, that they do it in astronomy too, shows stars. Yeah. And I would say, there it is, and everybody's like, he's nuts, because he's, I see it.
Yeah, it was kind of using your eyes the same way you use the
right.
scope
Yeah, I was
cameras,
integrating into my
Yep.
and then walk around blind the rest of the so actually, in the chip plant, we'd go into different parts of it, which is cool.
Yeah.
But it's all orange,
right,
to cut out. So you walk out and everything's purple for almost half an hour. It's a long time. So. But no, excellent.
But I just love these things, and things that they did with these. There was just some nice little shortcuts that nobody even really paid attention to. But on any of the old tech scopes like this, usually the trick is if you're a novice scope user, how do I get a trace, right? How do I get something to happen? And the way almost all these things work, if you went to the trigger controls and pushed the top position of every knob and pushed all the switches up to the top position, that was like auto trigger,
instead of
normal, auto trigger, maybe AC coupling, normal source, and then
crank your intensity,
and you get a trace, right? That was the kind of the default. Set all the controls to the top. It's like turning it to 11, so it's
plus the vernier was always fun to play with.
So because the version of the scope that had the DMM on it was a DM44 option that had a DMM at the top. And when you got that DMM option, you actually lost this vernier knob.
Oh, I didn't know that.
Because what would happen is they used the numeric readout. It was still a
Oh,
multi-turn knob here, but they used a numeric readout
as
the multiplier instead of reading the mechanical thing on the
I
knob.
gotcha.
But I always loved these mechanical
Because I
knobs.
just thought it was a true bullet. Now the option I loved though was the -05.
Okay, what
the
was that?
TV option.
Oh yeah, for the vertical and horizontal sync.
Yeah, for counting and stuff. And it's got like a horizontal sync,
trigger
a vertical
line 4.
Otter. When you got to the part, it says, "Well, do you want the otter even?" I'm in heaven at that point. Because back in the day, I was always building, and I have somebody else's that I found, but it's over there in a junk pile. I was always trying to build the thing that would find the thing. We even talked about LM 1881 came about. And so I was always trying to build my own TV sync so I could go find line 17.
Right.
On the thing. And so having it
built in the scope is like, oh, yes.
Yeah.
But this one doesn't have that option, so this one did come out of a TV shop.
And one day we had the VIC chip, which is the C64 and all those, and we had it was either the PAL or the CCAM mode. But when we sat there and went, okay, to line 17, then we do to line 18, you see the color reference flip polarity, phase alternating line, right?
Yeah, right.
And it was just, we're actually seeing the videos.
Yes.
Because the C64s were built wrong, the VIC chips. They didn't have the right number of horizontal. The timing was off. And in the days of horizontal and vertical holds, it didn't matter.
Yeah.
Well, as soon as the TVs came out where there was no vertical hold, they all rolled. I mean, we were, and I don't think we got the interlace right. I think we were missing a quarter or half of a scan line or something in the serration.
Okay.
The problem was due to them trying to do serrated horizontal sync pulses in the vertical sync.
Okay.
Somebody lost count.
Did I ever tell you my Commodore 64 story?
No.
Well,
By the way, Commodore was actually they're dinosaur technology these days.
Sure. Yeah. Well, I had a Commodore 64. I bought it new.
Okay.
I forget where I got Arthur's or something, maybe, who knows. But I had that computer when I went to college, or I bought it while I was at college.
Right.
And because at NJIT, most of the work that you had to do in some of the EE undergrad stuff was on kind of the mainframe computers there, where you had to submit your simulations and do your work like that. So you had your choice of either going to find an open video display terminal in the library or student center or wherever, and kind of edit your files and submit them that way, or do them on punch cards.
Right.
Okay. So you'll
drop it
box
off
of
on
the punch
the
cards
and
then try to run to class without the punch cards coming out of your hand, and
the classic stories are dropping the box. Yeah.
So what I wound up getting the Commodore 64. I had the 300 baud modem, a little plug-in modem that went in it, 9-inch black and white TV as the monitor, and I was living in the dorm, and a friend of mine and I went into the phone room in the dorm and punched in a three number extension to the mainframe. Okay. So with a separate phone line up into the dorm room. So with a 3-letter extension, I was dialed in as if I was.
I gotcha.
Okay. So boom, I was there. So I was able to kind of edit my files, submit my jobs. I had a little word processor, did all my things. It was great.
That's cool.
So it came time where I needed a bit more power than the 64 had, and I was getting an Apple IIe. So I was going that way.
I thought you said more power.
Well, a little bit friendlier power maybe is the right way to say it. The classes that I needed the IIe for whatever reason. So I
kicked the 2E's ass, right?
I know.
That came out with the C128 time.
I know you did, but so what the story was that I was going to sell the 64.
Right.
And I was selling it. It was the next year, so I was selling it to a guy. A guy who came to buy was I had just come through the year that he was doing.
Okay.
So I was all set up in my dorm room, and I was running some work on it. And the guy came to my dorm room and said he wanted to see it. So I showed it to him. I showed him some of the programs I had. I said, I just have to submit this job, and then I'll show you the rest of it. He said, oh, I'll walk down with you. I said, no, I can do it right here. So I boom.
Oh, that sold the computer.
Well, no, so he was looking and said, oh, that's cool. So I showed him a couple of the other things I had, some of the programs I had. I had the cassette drive and that kind of stuff. I didn't even have the CD. I just had the cassette drive.
Right.
So I said, let me go check to see if my run's ready. And he's like, I'll walk down with you. I said, no, it's just right here. so I brought that. He goes, oh, that's really good. I said, oh, my run's all done. I said, I'll just go get my output. And back then, the output, you had to go back. You had to actually go into Weston Hall. We talked about Weston Hall earlier. And it was a big, bins against the wall. And your 19-inch wide green bar paper would be out there. He goes, I'll walk down with you. I said, no, I can just go download it here. And I started printing it out. And as is the dot matrix printer's printing is like, how much do you want for this?
Yeah, it sold itself at that point.
So I think I sold the whole kit and caboodle of everything for like $600, which was probably $200 more than I paid for it. So.
Right, and things like the printer. I mean, that was, peripherals beyond reach until around that time.
Yeah, that was Secocia. Is that who made them? But it was a dot matrix printer.
Was it ours?
I think it was, and the descending characters didn't descend; they were just kind of scooted up on the line.
That was the Atari font. If they were using the font we used on the screen,
but
we didn't have descenders.
It was an 8-bit or an 8-dot,
8 by 8
an
cell.
8 by 8 cell.
Yeah,
and it was horribly loud because the print head would bang against like an aluminum platen.
Oh sure.
All right, and the thing was. But
they were notoriously loud. All of them from that. I'm sitting there trying to think. I'll think of the. I think we used a lot of Seiko and stuff.
Yeah, I think the one I had after that was
Mitsumi's.
An Oki Data.
Yeah, okay.
Oki Data Microline 92. That's what it was. I remember that one. So.
Yeah. So and we, even though we charged more for, but you couldn't get a printer back then until you got these kind of things.
That 64, I remember.
We grew up tearing the tabs off the sides. I mean, another dinosaur thing.
Oh yeah.
You talk about spending money. I remember when I bought my first laser printer, I drove to St. David's in Philadelphia, and I'd saved $1,200 or something for a HP 4 or something,
crazy.
4MP or something. Yeah. Well, I was the only guy I knew with a laser printer.
Yeah. Well, I didn't know anybody with a laser printer, but I said that 64. I mean, I remember what Compute magazine. They used to have you can get your programs that were printed in the opcodes. You had to punch in all the opcodes for that. I punched in word processor, punched in a bunch of other things for that, but. I remember even back then scheduling your classes at NJIT to register for classes was always a pain because you had 6 classes you had to take. Each of those classes would meet, they'd have 5 or 6 different sets of different times that would meet during the week, and to try to assemble a schedule with all that was just a nightmare. So I remember writing in BASIC this brute force program. It just was a nest of 4 next loops. A nest of 4 next loops. So you spend an hour or 2 hours putting in all the data for all the classes you had and hit run. And I'd get up the next morning and I'd have a printout of all the classes and all the combinations that would work.
Right.
Okay, and then I'd go through and sort them by which ones had Monday mornings off, which ones had Friday afternoons off. Then you bring them all down to the registrar when it's your time to go and say, okay, let's try this one. No, try that one.
That's cool.
So
yeah, we had a guy at Commodore. We had hanger-oners. We weren't sure what they did. But often they had family that worked there or something.
Yeah.
And one guy, he'd written a basic program, and his job was to every night he would take the work everybody else did and have it go look for the same occurrence of assembly code, and if it was more than 3 times, then it made sense to do it as a subroutine.
Okay.
So he would look for subroutines, all in BASIC. But that was, did you hear the amp hour with Chuck Peddle?
Yes. Yeah.
And he talked about you couldn't get into the computer centers,
right?
Because people were actually trying to take access to them and stuff.
Yeah.
So that firewall was literally that place where you dropped your cards off. You were saying, and I didn't. You take it for granted when you're saying, well, we try to decentralize computers. Well, what's that mean? Well, terminals didn't have processors.
Right.
The only processor was the one behind it. Right. And he's like, the terminals should also think.
Yes.
Of course, now we have MDOs. That
Right.
think,
Yeah. Right.
So,
Or PDAs and smartphones
way
and
too
all that
much
kind of
crap.
stuff. So, but yeah, that was fun times.
yeah,
So.
yeah. So what else we got another yes, one more thing.
Yeah, one more thing I got to bring here.
Yeah. Oh, there's a name for this too, where it's formed by an impact with it's like beat shotted or something.
Okay,
like that.
yeah. But just so amateurs, but I did power it up once to see that the Nixies work, because that's all I really wanted. But I think I paid $1 for it. It was like in a junk pile at the Dayton Convention.
Now, do you know why screwdrivers were flat before they were Phillips?
No.
Why? In the early days of early production, that's how they did their torque control. To when the head was torqued is when this would spin and it hit the final torque, it would slide out of the slot. So it was meant to leave, like the part we hate, it was designed to do.
It was designed to do that. Okay.
Yeah.
Didn't know that. All right. Yeah, so I just thought this thing was
in
cool.
Japan, they call it a minus and a plus.
Right, yes.
Screwdrivers.
Right. So, but just the fact that this whole thing was kind of built as this kind of card modular type of thing, and it was actually one of the sets of boards here. One of them is broken. Yeah, this one. I think that's the one that's broken.
Well, first let's start by telling us what this is.
Okay. So what this is, it's actually a frequency counter, but I didn't pick it up.
Keep talking.
Okay. It's a frequency counter, but I didn't pick it up to use it as a frequency counter. I picked it up because it has 6 Nixie tubes in it. And I kind of had a thought one day, I want to make myself a Nixie tube clock. It's just kind of a cool thing. I love Nixie tubes.
Yeah.
If you've ever seen any of my videos, one of the frequency counters that's on my bench is an old Leader 60 megahertz frequency counter that's got Nixie tubes. I just love using that thing.
Yeah.
I've got a more modern Tektronix, really nice frequency counter, but I like the Nixie tubes.
Well, and my first Heathkit, maybe second, maybe the grid deep meter was still say grid, right? But it was a digital voltmeter with the Nixie tubes. And the way the little board was supposed to plug in, it had connecting wires, and I wasn't very neat, and I was mashing it to get it all into the... And when I grabbed the leads, I caught 180 volts off my own. So I hated my own voltage. I didn't trust it. It was like, but I knew without a shadow of a fact, that Nixie tubes took 180 volts after that.
Oh, absolutely, you did. Yeah. So, but what I thought was neat about it, I bought it because I wanted the Nixie tubes to build the clock, and I thought maybe I'd even build a clock in this case and just use the whole driver and everything that's built in there. But that's the reason I got it. But when I got it home and looked at it, there's just a couple of interesting things about the way things was built, and I thought it'd be an interesting thing to show. The frequency reference right here. It's an ovenized reference plugged in.
Okay.
Okay.
Yeah, let's
put it
on
on the camera here.
Yeah.
So this is the 10 megahertz. I think it's a 10 megahertz reference. I got to go back and take a look at it. But it's basically a plug-in thing, and you can see it's got an oven in it, so it's ovenized. So it would take some time to warm up. And there's actually, you can see there's actually a coarse adjustment screw right at the very beginning. But that literally just plugs right into a socket here, which I'm not going to be able to find now because it's a tiny little socket you can't see when you plug it in there. So we'll leave it off.
It'll rattle all the way home. And you could always tell classy with the cap covers, right?
Well, actually, those actually, yes. So there's the paper capacitor covers, But just a neat thing. And the whole thing was kind of built in this kind of card modular, type of structure where you can actually just grab one of these sockets are really tight. I don't know if I can get one of them out of here. I might need a pair of pliers to do that. Let's see if I can get one of these out. There we go. There we go. So just look at these cards. Single-sided, plated boards, but all hand-taped.
You can always tell, but they're not straight. They're
they're all just curved. The guy literally is like laying down pinstriping on a car. This guy just hand-taped all these things to kind of lay out where the resist would be.
This literally looks like if you were to make your own board, it'd look almost exactly like this.
Yeah, if you were drawing out with a pen or something.
Especially since it's not gold fingers or anything.
Right. Yeah, and there's no solder mask on these things. These are all
no feed throughs.
Completely soldered. There's no feed throughs. It's all single sided.
Yeah.
Bunch of discrete transistors, a bunch of resistors.
I had a real thick book that I used as my backdrop for drilling. When I drill.
Yep. Yeah, let's pull another one of these things out here because this one's got a couple more components on it. So, but all discrete designs, which is love about this thing. I mean, so it took some talent to kind of lay this stuff out back then, but all complete discrete designs. I haven't been able to find any documentation on this to kind of get schematics or anything like that.
So, and you're probably like me. When you see color codes, you probably still see values for at least most of them.
For most of them,
there's some I've lost.
Yeah, I'll pick out 10K resistors all day long.
I just went right for a 1K.
Yeah, right. Yeah.
So and that was in the day. the way I learned resistor color codes with TV repairman was in the house, because they always came in your house. Everybody had a TV, and he just held up a red, and he says 2.2K. Yeah. And then you learn 33K, orange, and then from there you learn.
You just learn them all, yeah.
But where it becomes important then is when you're doing TV repair, if you look at a value and it's not a right value, and you need to recognize, well, it's not the right value because heat has ruined it. Yeah. So the orange became brown. Yeah. So wait a minute, there's no 310, something like that. And so knowing the color codes instinctually really sped you up in TV repair. Yeah, and one thing that is a bit of a lost art now too, and I try to do this when I build stuff, is if you take a look at this, all the resistors are in the same orientation, meaning all of the tolerance bands, in this case, are all at the bottom. So you could read all the color codes the right way. They didn't flip them around end for end. So they took some care, and when they assembled it, to kind of make sure that it make it easy to kind of go back and go look at values here without having to turn them around. And this would have been hand assembled. I think because there's nothing that's specifically on a grid or a row here. You probably didn't do enough quantity to do auto insertion. Yeah, make maybe a couple of hundred of these. Who knows? Yeah, but so that would have been the assembler, and certain assemblers probably are coming from production. Yeah, maybe not everybody did it, or maybe it was the shop's thing, or maybe some people said that's how I do it, and they like that extra. Yeah. And like getting your transistor heights. Yeah. Where it's not leaning, that one's actually leaning a little bit. I might have grabbed it when I pulled it out of here. But and they used to try spacers. Yes. That was a bad idea. Yeah. We thought it was a good idea, but it was a bad idea to get your transistors to. Yeah, it was interesting. If you take a look at the bottom of this thing, it's actually there's a piece of paper at the bottom of this thing. It's not the schematic, but there's some information printed on that. Okay, so it's not yellow just piece of paper. Back. No, there's actually something about yellow copies of the FAA form. So I wonder if this is actually paper this might have just been laid in here as an insulator. Well, that's why I'm thinking it might be, which we used to call fish paper. I'm thinking, I'm just looking at the way it was cut, but it almost looks like it's trying to say something else. Yeah, because this list says something about FAA, which is the Aviation Administration, Form 406 and it just ends. The transformer. That's unusual. Yeah. I'm trying to find, is there a year on anything here? So that doesn't have this used to be our bread and butter for switches. Oh yeah. And nowadays I don't even know if you could get like a multi-wafer switch that had enough functions you could invent something. Yeah. You wouldn't even want to. Like even this one here, I don't know if you can see that one on the camera here, but this one's got components mounted right to it there. Yeah, so, which was way we and even those solder the not fan stock, but the solder strips we used to. Whole TVs would be built. Oh yeah. Well, this was the input attenuator, so the RF signal, whatever frequency range this would cover, would go right into this. And be attenuated so rather than run wires out to a board, they just put all the attenuation components right on the switch, which needs to be tightened, as you can see. There. Yeah. So so there's RF signal coming in. You can see the coax running down here. And if you look at these things, I pulled a couple of these boards out in the past, and a lot of them are very similar because it's really just decade counters now. Right? They're all just discrete decade counters. Yeah, I'm looking at the part numbers. Yeah. Yep. There's some identical part numbers here. Yep. Yeah, so that's not a dig. Just a pretty cool thing. So I thought if I dig up some documentation and get where like the driver board and stuff like that, I thought I might be able to reuse some of this and turn it into a clock. It's still a clock. It's just got a big chassis with it. Right. So I thought that'd be a neat thing to kind of have as my shop clock or something, but. I just thought it was kind of a cool thing to bring, kind of show how stuff was built back in the day. I think I did a video a while back on an old, I think Exact Electronics function generator that I have, function and sweep generator that I have. That's probably from the mid '70s. But the construction it isn't modular like this. It's a single board, but it's a single board. I don't remember if it was double-sided or single-sided, but definitely a hand laid out board, all discrete components, maybe a couple of op amps or something like that, some 741s or something, but that's really what that was. What we learned in design is, from my era and stuff, is because we had somebody actually try and design it. You can't troubleshoot and debug this stuff worth of crap while it's in a card case. Oh yeah. So you get the extender boards and stuff. Extenders, and at those speeds, the extender didn't hurt you like it would at today's speeds. Yeah. But no, it's so this was always the shape of a final product, but in product or R&D, spread that sucker out. Oh yeah, yep, all over the bench. Well, yeah, it's just a cool thing. Yeah, I know. It's actually, I think I picked it up at Dayton probably 10 years ago, and you can see how far I got with it. But it's one of those back burner projects. Dayton is a company. I'm sorry. City, I assume everybody I talk to is electronics is a ham radio operator, so that's what Dayton is. So for hams, every ham knows that Dayton means the Dayton ham vention. So it's an actual event.
It's a 3-day, electronics flea market. All the ham radio vendors come out. Everybody comes to sell their junk. It's a huge.
And where's the held?
Ham Fest in Dayton, Ohio.
Okay. So. Which I lived there. Home of Wright-Patterson Air Force Base.
Yeah. So it was actually at the Harrow Arena.
Okay.
So if you're familiar with the Harrow Arena,
I was like 3 or 4 when we moved out. But by then, I knew what a B-52 was.
Okay.
I knew they had a B-36 pusher prop right on the edge of the property.
Oh, wow.
Yeah.
Okay, very good. So, in fact, my last trip out there, I wasn't out for the Dayton Ham Vention. I was actually out to Wright-Patterson. And then on the way back, I actually stopped and met Chris. That's the first time I'd met Chris. Actually, it was the first time I met Chris in person, Chris Gamble. He lives in Cincinnati or outside of Cincinnati, so I was passing by there on the way home. Or Cleveland on the way home.
So have you been on Amp Hour? Have they ever?
I have.
You were. That's right. You were on an early one, weren't you?
Yeah, I was on the Amp Hour. I think in October it'll be 2 or 3 years. 2 years ago, 2 or 3 years ago. But this October, so that was fun. So I met up with Chris in New York City once or twice too.
Yeah, I just saw him like 2 weeks ago, 3 weeks ago. He was with us up in New York for the Disrupt New York.
But so I've met Dave. Dave Jones just through email.
Well, so's Chris. Chris never met him in person. I just asked him. Yeah,
we'll have to get him over here at some point.
So yeah. Oh, very cool.
Yeah. So those are the YouTube channel. That's like the YouTube channel I aspire to. Because I always joke with him that I'm 10 dB behind him in terms of numbers of subscribers and numbers of video views. I'm about 10 to 12 dB behind him. So
well, the amount of effort, obviously, and time it goes in. I wouldn't want to be like anywhere near successful.
And it's his full-time job.
Right.
I already have a full-time
But the time
job.
he started, there's that curve, and he caught the wave. I'm assuming, that he was already instantiated before the other.
Yeah, well, and he's got the forum, and he's got
Well, again,
all
that's
time.
That's
all time.
Yeah.
And me, I'm lucky if I can do a video every 2 weeks.
Well, and you've got a tremendous number of videos.
I've got 200. I think I just did 201.
Yeah, and I say tremendous because I know how much it takes to do a video. So I've got 16.
Yeah.
and it's taken me a year.
Yeah, and like I said, we were talking earlier
25.
that what people don't realize is when I do some of the technical videos, it's at least a 30x overhead.
Yes.
Every minute of video is a half an hour of
and in your case, you have to. Well, I was going to say you have to get all your equations math right because you do a lot of on screen. Yeah. But I think we both learned don't do math actually on the screen if you can help it.
Right. Oh yeah.
Have it because
if you look, especially my earlier videos, which were more stream of consciousness, where I'm actually holding the camera and doing that kind of a thing. You do the video, you post it up there, and then you just like,
everything's right except the actual numbers. I'm saying,
or I said something completely wrong. So all those videos got little peppered in little annotations here and there, correcting the things that I said on camera. So
and when you're thinking about speaking, which is like for an engineer, not necessarily your first language to begin with, is actually your mouth.
Right.
And I know when I do it, it's just I can't even believe why'd I grab that word,
Right.
And people are like,
where did that come from?
Come on, I'm thinking about a dozen things at once and trying to make it entertaining,
Right.
So yeah. Oh, very cool.
Yeah,
so, have you powered this one up yet?
I powered it up once when I first
saw
it
you got to
10
see
years
the Nixies
ago.
turn on.
Just to see that the Nixies turned on. I may have put a signal in it to see if it kind of worked.
Right.
And the fact that they came on and nothing blew up, it's like, okay, let me turn it off before something and smoke comes out.
Yeah, and you probably got away then without those caps being not too bad that they probably started
if they started to heat up or anything like that, I shut it off before they got exciting.
Well, and one thing I'd forgotten about Nixie tubes till Fran was reminding me was they need something to set off the excitation, a gamma ray or a little bit of infrared.
I didn't know that either until she went through that.
Once it was like 3 days after she had told me the first time, and then finally the old brain goes, here's the part that you knew back, there was something that.
Yeah, I never knew that until she went through that.
She actually said like deep in the mines they wouldn't turn on or something.
Yeah. Well, what I really like about Fran is she really goes into get into the details of that kind of stuff. Like she did the same thing
like
with
the chemistry of something or
that,
the materials.
That launch vehicle computer, going down and debugging all those little hybrids and tracing them out and reverse engineering that stuff. It's fantastic.
Yeah.
So, but I kind of get down to the circuit level, but that's about it.
And I think as a designer, I'm more trying to think how to put things together than take an old thing. When I was young, it was a way to learn, but kind of now I'm not so much into tearing apart a TV set. I already know what a TV does.
Right.
But so I'm not quite as into the historic stuff. Yeah. But I also don't get exposed to it. she collects stuff, being in the city and stuff.
Right.
That's why most of the time the stuff we show is hers. I'm out here. I'm going to buy something from DigiKey.
Yeah, right. You're not going to find something laying on the side of the road out here. I just drove up here. You're not going to find anything.
I'm trying to get rid of my TV. Well, you saw a toilet and a TV out at the end of my driveway. So all right, so kind of wrapping up. You started with a strange series. I know what they mean, but the days of being who you were was based on it was on your license plate at one time, probably too, right?
It's on my license plate on my pickup truck in the driveway right now.
So we're obviously talking about your call sign,
right? So W2AEW. It's obviously just like on license plates you can get a vanity license plate. The W2AEW is a vanity.
Right, and sure.
And it's my initials. The AEW are my initials.
And how long you been doing ham?
I was originally licensed as a ham radio operator in 1979 or 1980. I was
and did that correspond? Did you have to have your second class or your first class license?
No, it was a separate thing. I was actually in high school, and the electronics teacher, we were lucky enough to have an electronics elective in high school, and my electronics teacher was a ham.
Okay.
And he started an amateur radio club in the high school, and I think the ulterior motive was he wanted to get free labor for the students to help put up antennas and have an excuse to put antennas up and having a ham radio at the school. So we actually built a little shack and everything. So
that's cool.
So I was originally licensed then as KA2IZZ. That was my original novice license. License. So it was a nice pattern to it in Morse code, because a I is a dit and a Z is a da dit. So the suffix of the call is.
So you're doing all this in Morse code during this time too.
Yeah, because back then there were actually, the 1970s was 5 classes. So it was a novice, technician, general, advanced, and extra. Okay. And so the entry level license was a novice, and you had to do 5 words a minute Morse code and pass a multi.
I could send a lot quicker than I could receive.
Yes. So but that was when I was originally licensed. I was licensed through high school, but then college, girls' job, I kind of dropped out of the hobby. I got back in probably 15 years ago, and so I had to come back in kind of starting all over again.
Right.
So I came in at that point as a technician class licensee, and I was KC2 BOG. And then
you don't forget your call sign.
You don't forget your call signs. But then
Army guy never forgets his own unit.
So then I quickly went from I upgraded from technician to general and then advanced. And to do an advanced class license, you had to do 13 words a minute at the time, and then it was a written test or a multiple guess test, multiple choice test. And so with that license class, the license classes would determine the structure or the format of your call.
So, okay, I was going to ask. So, how do you talk to somebody if there's a delay between understanding? As you get better, you can converse, right?
Yeah. Well, the thing is, the license class tells you what mode you can operate in and what bands you can operate in.
Right.
But the structure of your call sign was also like the higher level classes could have like what's called a 2x1 or 1x2, like a 1 letter, a 1 number, 2 letters, like a 1x2.
Okay. Well, you got juicier call signs.
Yeah, you got the nicer, shorter call signs.
So people, it's like credibility, right there in your.
So when I got to the advanced, I can get a 1x3, which is the 1 letter, which is what my call is now, 1 letter and 3 letters. So and then the extra classes could get the 1x2s or the 2x1s.
Did you get to pick what from available?
Yeah,
ones?
so you have to kind of go see what's available.
Right.
And
it's kind of like picking a company name in Jersey right now.
Yeah, right. But so I figured if I pick my initials, I'd still remember my call sign when I got old and stuff was leaking out of my head. I'd still remember my call sign. So that's why I picked W2AEW. So it was actually a couple of years ago. I got the call probably 10 or 12 years ago, 12, 13 years ago. I changed over. But a couple years ago, I started thinking, well, who else had this call? Because somebody had it. It was issued probably sequentially by the FCC to somebody before I had it. Right. So doing a little research, I found that the call was originally held by somebody actually down here in South Jersey, in Glendora, probably not too far from there.
Right.
Okay, there's a guy who had
the
call.
It's 1 square mile. Glendora is 1 square mile. Yeah.
So he had the call I found out probably from the 40s up through maybe even the early 60s.
Okay.
So, but then I don't know if he changed or what happened to him.
Or the internet happened and
or he's gone, or who knows, But, but if you had the call in the 40s, he's probably maybe a silent key. That's what we call deceased hams, as a silent key. He may be a silent key now. I don't know. So I figured, okay, well that's neat. It'd be fun if I could find a QSL card, because we used to exchange from him. Right.
Or at his. Because that's part of what you did. You would send them to each other after talking to each other.
Yeah, you confirmed the contact. That goes back to the old shortwave listening days, where the shortwave stations would want to know how well their signal was getting out.
Okay. So it was a
if you
signal.
wrote to them and say, I heard you at this time of the day, and this is the programming you were doing, and this is what your signal strength was, the radio station would send you a confirmation postcard back. Right. They usually had pictures on them or something like that. So that tradition carried over into ham radio. So that's where that came from.
Because I remember seeing walls of that stuff.
Yeah. So I got a card from this guy, Walter Holt, was the guy down here. Walter, I think that's what it is. I think that was his name. But anyway, I got his card. It's like, oh, cool. That's the history, right? I figured nobody else had it before then. So I was doing I had a friend of mine sent me an email a couple years ago and said, hey, look what I found on eBay. People selling used QSL cards, and there's W2AEW. And it's not this guy from Glendora. It's somebody from Scioto, New York.
And it just happened to be one they showed the picture of.
Well, it's what's the one that they were selling.
Okay, so you're selling them one by one.
Yeah, they're selling them one by one. W2AEW, this guy in Scioto, New York, from the 1930s.
Okay.
Cool. So I got that one. So now I have my card and these other two cards of other people that held W2AEW.
Right.
So it's like, that's pretty cool. But then I'm thinking, back in the 20s and early before that, when the FCC was trying to just forming and ham radio was just kind of coming together, the call signs for amateur radio operators were a number and 2 or 3 letters. It didn't have the W or N or A or K or whatever in front of it. So I figured 2AEW was probably issued to somebody.
Okay.
Right? So I did some more research on that and found out that 2AEW was held by a guy who was pretty instrumental in RCA at Sarnoff in color television development.
Okay.
So I got because
Sarnoff Labs.
Yeah, Sarnoff Labs, but it wasn't Sarnoff that had it. It was a guy that had it, and it was interesting. This guy had written kind of a like an autobiography a little bit, a technical autobiography. So I found information. I was like, oh, that's great. So I'm still searching to see if I can find a 2AEW. But in my searching for it, I found 2 other guys that had 2AEW before him. Going back to like 1913 or 1914 or something like that. So there's at least 3 people that had 2AEW, and now 3 people that had W2AEW.
Yeah.
So
I wonder how many people were hams back then, because
probably not many. I mean, you got to figure because
So I would have
it was
thought
probably in the thousands or tens of thousands, maybe at the most.
So not like it was this whole media that was there because there was no alternative. I would have thought, being electronics, I would have thought, there have been lots of hams then, because there was
not everybody,
nothing on TV that night.
Yeah, it's just not everybody could, not everybody could afford to do it. Not everybody had the technical talent.
That's true.
And there wasn't equipment you could buy. Everything was something you built. Right.
Oh, that's right.
Right. You got to figure in the 20s, you couldn't go out and the 20s you could start to buy stuff, but before that you really couldn't buy anything they could use on your own frequencies. So people were doing spark gap transmitters and all kinds of stuff like that. And
I'm assuming tin cans got used as.
Well, this typically the hams were kind of relegated to what was called 200 meters and down.
Okay,
which was basically all the HF frequencies that the government
that's
at that
typically
point.
the noise that comes out of a computer I design is in the 200 megahertz.
Yeah, but those frequencies are kind of deemed useless. It turns out that the HF frequencies are the ones that propagate around the world better.
Yeah, right.
So so antennas obviously are bigger because the wavelengths are longer.
Yep.
So, but mostly big long wires and stuff like that. Then, but
which are cheap too, compared to like a Moonraker or something.
And that's all I use. I've got a 130-foot wire dipole strung diagonally across my backyard, and I got and
some lightning protection.
Yeah, and a transmatch to match the impedance. So.
That's cool.
But and people, so you could spend a lot of money on stuff.
Is the hobby still going strong, or is the internet taking it?
Well, there's a different. People get into it for different reasons now.
Right.
People get into it because they're interested in the technology or like playing with buttons and pushing knobs and that kind of thing, or they just like communicating. They don't get into it because it's the only way, or some people get into it for the public service aspect of things.
Well, and that's the way I knew it. Like during and when I was in the Guard, I was always getting activated, and we'd have somebody from the ham show up and set up in a corner, and I would usually set up the radio that talked our way, and they would talk their way, and somebody would talk between the two.
And the thing is, I read an article just a few months ago that there are more licensed hams in the U.S. now than there ever was. It's already it's recognized. So it's still growing. It's not growing tremendously, but it's just still growing.
Now, are they using it for voice, or are they still using it for Morse? Because you can get auto Morse generators too and stuff.
Those are just 2 aspects of many different. I mean, I'd say the majority of it is voice or phone. Either on FM for higher frequency stuff, or single sideband for lower.
I remember it was a big thing back then was phone interfaces, and that's how you could call Korea or something.
When I say phone, I mean voice. So we call that phone.
But there was a foam repeater type thing going on too.
Yeah, one of the very, very popular things, especially during World War II and things like that, and during the Korean War and stuff, is called a phone patch.
Right, and that's
like Senator Barry Goldwater was actually a very active ham, and one of the things that he actually did was run phone patches for guys out on the ships and things like that, so they could talk to people.
It was a public service for the soldiers and stuff. And people get married on it and everything.
But there are still a lot of people that are Morse code enthusiasts.
There was a video. It's not called QAMP, something like that. There was a name for one of the video formats. Slow scan.
SSTV. Slow scan. Yeah. So slow scan TV is a way of transmitting images. There's also there's other modes where you used to have effectively a modem, okay, to do the same thing you'd use the old modems
modulate, demodulate your signal.
But nowadays, most of that's all done with sound cards and computers.
Yeah.
And there's lots and lots of digital modes that do that. There's one very popular one called PSK31, which is phase shift keying at 31 baud.
Okay.
Very clever name, but PSK31. And basically, the baud rate is about as fast as an average typist.
Okay.
So it basically is a keyboard to keyboard text thing live, so you can actually see how fast someone's typing. You're looking at your screen, you actually see them typing to you, and you could be typing back to them.
Right.
But that's a very popular mode because it's so narrow or so slow. It's very narrow in bandwidth, so that signals could be buried in the noise, but because the software
it's so discriminating.
It's so discriminating at that point, and the SNR can be you can't hear the signal and you can decode it.
Yeah.
And there's even more weak signal modes. One called WSJT, weak signal. Oh, there's a couple of weak signal modes, JT65.
Well, and
things
I had seen some of that where they integrated
Yeah.
out, and that's why I asked about integration earlier, which you'd see it build it, but it took what is a long time now for us. But
there's actually another thing people do called weak signal propagation reporting, WSPR, WHISPR. Okay, kind of appropriate. And a lot of these were developed by a guy named Joe Taylor, who lives actually in Princeton.
Okay.
He's a Nobel Prize winner, but it really is. But he developed like this whisper thing, is where you could build these little tiny beacon transmitters that could be 5 milliwatts, 10 milliwatts, and they basically send effectively an FSK.
Right.
But you're doing a frequency shift by a couple of hertz. Okay, in the 30 meter or 10 megahertz frequency band. You're only shifting by a couple of hertz, maybe 5 hertz or something like that.
So it's still very narrow bandwidth.
Very narrow bandwidth, and also very, very slow.
Right.
So like it might take, I've never really played with it myself, but it may take a minute to send your call sign, or 30 seconds to send your call sign. But the whole thing is,
can you pull that out of the noise?
It's a weak signal propagation reporting. It's not intended for communications, but you put this beacon up, and people have got grabbers or receivers all over the world.
So are they doing things like plotting like the F layer and stuff? Or the effects of it?
Yeah, these scanners are actually pulling out, and any signals that it can hear, it'll decode, and then basically online post a map.
I was going to say, so you would get things like moving connectivity.
Yeah, you can actually see the
paths, and that would correspond to things going on in the upper ionosphere and stuff, I would assume, and other things.
Yeah.
But
and just being amazing to have a 10 milliwatt transmitter here on the East Coast and have it heard in Russia. Just 10 milliwatts.
What's a satellite right now? What's their transmitters?
Well, the satellites typically are. I'm not sure what power they're using, but the satellites are typically, usually they'll be dual band. They'll be uplink on one frequency, downlink on another.
But I was thinking the downlink where they don't have much power, wasn't that like 50 milliwatts? And
they're probably less, a few watts or less typically.
Yeah. I knew it was real small. Hence the dish.
Yeah.
So that's cool. As far as hams and computers, the one thing I had always seen was the VIC-20.
Yeah.
Was one of the early things adopted by hams, and what they didn't know they were getting out of it is the C64 is extremely noisy, partially because it doesn't work very well, and a lot of not working is contention on the buses.
Okay.
I mean, contention is current is noise.
Right.
Well, the VIC-20 didn't jump on and off the bus at all. It's just a 6502 going, here you go.
Yeah.
Here's another. Have fun. And so very quiet. So and I've seen those actually like in backpack arrangements and stuff. Sure. You see pull out a VIC-20 and it's got his hand patch. Yeah. So that's cool.
It's funny. One of the things that I did kind of as a side project during my downtime when I was working at the Army is I actually taught myself 6502 assembler.
Yes.
And I actually wrote the first assembly language programs I actually wrote hand assembled and then hand poked in. I did this on the Apple II, Apple II Plus.
They did it on the Chem 1. They would hand poke in the because there was no keyboard.
Yeah.
So it was.
I wouldn't know how to do it now, but I did that.
Yeah.
So.
Well, that's how I got my job at Commodore. Final story, and we'll wrap up.
Okay.
Because I was working at a digital scale company that we had a 6502, and we actually one of the chips that's on the Chem 1 a single board computer is a 6530, and they have -002 and 003, which is the ROM version. So they had the we had 005, so we had the fifth. So we were an early adopter. And so I had learned 6502 assembler as I was an associate engineer, then a normal engineer. I go into interview for Commodore, and first guy I talked with, I ended up becoming friends with him, but during the interview I did not click, and I'm trying to click really hard, right? And he's like, I mean, he just wasn't impressed with anybody.
Right.
So I'm like, great, I've just blown it. And I go into the second room, Bob Russell, who had done some amazing things. But as he's talking, one of the things he does, he says, well, I might tell you to load X immediate 05, and I'm going A205. I'm mumbling him under my breath, and he goes, store accumulator, I'm going A203. And that was it. His body language saying, well, we'll have you come down to the plant and everything. Funny. So literally my that 6502-ness about me was what got me in, and it turns out that's what was neat, because you just had to live, breathe, and eat that stuff.
Wow.
So.
It's like, I thought it was the documentation that came with an Apple II, my dad's Apple II Plus computer.
I've not let anybody say the word Apple this many times before.
Anyway, that's how I learned 6502, was actually from that documentation that came with that computer.
Right. And you know my feeling about Apple, right?
I know.
They just used our chips. Okay. As a matter of fact, I think Chuck Peddle even went and got it working for him. But, and he was selling 65. Yeah. That
was good.
Well, hey, this has been Bill and Alan from Dinosaur Den, doing a kind of a guest one here. But lots of cool things here, and I really thank you for making the drive down.
Well, thank you, I appreciate it.
So, and
my pleasure. Sorry I wasn't able to meet Fran. So.
Yeah, but and I'm sure you may see a couple things here. We're going to keep talking, even though the camera turns off. Maybe we'll show up some other video channels here too.
All right, very good.
So again, from the Dinosaur Den, have a good one. We'll catch you around next time.
All right.